Good morning, everyone.
Sir, I have one question.
In
Yes, sir.
difficulty in
This
contour
question is related.
exercises.
Sir,
Okay,
my name
I
is
will
Sushant.
repeat
I need.
Good morning, sir.
after this practical session. Yes, please, Sushant Acharya.
Yes, sir. So I had this question related to one of the subjects. Like we have Python programming in this, like R programming in geoinformatics, because the industry is currently using Python. Is there any scope of using Python in this?
Sorry.
In currently GIS, we have a subject which is following the R programming language.
Yes.
So is there any possibility that we can use Python also as an as a elective or something? Is there any scope to use? Suppose if I'm trying to do a project like for my final semester, is it okay to use Python programming language?
Yes, Python and Google Earth Engine and one more WebGIS is taught in the third sem, if I'm not wrong. So it's there in your syllabus.
Okay, in the second semester we have R programming language.
In the second semester, you have Saga, Grass, and R programming. While in the third semester, you have uh, that Google Earth Engine, Python, and WebGIS.
Okay, okay, okay.
You can check the syllabus also. Yes, please, Rahul Pamar.
Sir, I have requested to access the drive yesterday, but not received the access till now.
Have you wrote your enrollment number, name, course code,
Yes, yes,
etc.?
yes, sir, yes, sir.
Okay. Yeah, you can write to Deshmukh sir. You have the contact number, so
No,
he
sir.
will.
Can you please write down his contact number in the inbox?
Are you in the WhatsApp group?
No, sir.
Okay. You haven't received any mail from the IGNU?
Actually, this semester I haven't to join the WhatsApp group or something like that.
You received the mail regarding WhatsApp group, na?
No, no,
Or
no, sir.
how did you get this schedule?
I just got the schedule, but not the WhatsApp link.
From where you get this
I,
schedule? Mail
on
or
email, just a single PDF.
okay. In that mail, check that must be a WhatsApp link. You are in which batch?
January 2025.
Okay, January 2025. Then see the earlier mail which you got for the first semester in January
Okay,
or
okay,
something. There must be a WhatsApp group link.
okay, sir. But you just said that I have to contact with Dr. Deshmukh, so it would be a great help if you can just write down his contact number.
Yeah, he's also in that WhatsApp group. If you want, you can write it in WhatsApp, or if you want, you can message him personally. But it will be better if you write in a WhatsApp group.
Actually, sir, I'm not in the group. That is my concern. And I got the link for the WhatsApp, but the request to join the group has still not been granted.
Okay, I will write down sir's contact detail in chat box.
Yeah, yeah. Thank you so much, sir. Thank you.
Okay.
Good morning, sir.
Good morning.
Sir, my concern is that can I get the like yesterday's class link or Google Drive link?
It was recorded by study center. You can contact them.
Okay. Also, sir, I am not in WhatsApp group. Benita sir has sent this schedule to me. So
Did you get any mail?
No, sir. I didn't get any mail. In fact, in the last semester also, I qualified the first semester, but I never get the any like mail from IGNOU. Even I have written to IGNOU, but I never like get the email.
Okay, you have contact letters of placement, sir, no?
Yes, sir.
Okay, then you can write, sir, for the access and WhatsApp group link also.
Sir told me today itself I like a word with him, and he told there is no specific group for this class.
You are in which semester? Second semester, no?
Yeah, second semester, sir.
PGDGI or MSCGI?
PGDGI, sir.
Which batch?
2023 July batch.
July 2023. Wait a minute. PGDGI.
Yes, sir.
You are in the group?
So I'm not in the group, sir.
No, no, you are in the WhatsApp group of PGDGI July 2023.
Yes, I am in that group, sir.
So all the information will be shared in that group only.
Okay, sir.
Uh, you can check the WhatsApp group. You must have got the drive link regarding uh, lab manual of first semester and second semester also in that WhatsApp group.
Okay. So yesterday's class link is possible, sir? Can I get yesterday? I missed that.
It was recorded by study center, so you can contact study center.
Okay, okay. Okay, thank you, sir.
Yep. Is there any other query related to yesterday's class? Or
Sir, good morning, sir. Sir,
Mhm.
yesterday you taught us how to do the contour mapping and then how to generate them from it. So I tried that yesterday.
Okay.
Unfortunately, I couldn't get the results. So if you could kindly explain us again, it would be a great help, sir.
Okay. Where are you facing any difficulty in
Sir,
generating?
I was able to generate contours from them.
Okay.
Then when I activated my plugin in Grass, I
Okay.
mean in the plugin, and then I went to Grass. Then I created new map set.
Okay.
So after that, I try to open the map set. Still, it is not covering the contours. It is like giving the entire shape of the India. Like it's a very huge. If you can share my screen.
Yes, please.
Okay.
Good morning, sir.
Sir, is my screen visible, sir? Hello,
Yes, it's visible.
sir. Give me a second, sir. Give me a second. Sir, I was able to do. I generated the contours like this. So then I went to plugins, grass, created new map set. Uh, then I did all of this. Then all this, I think I did correctly only. Then I opened that map set. I got in this fashion. Then Then only I was not. Give me a second, sir.
You are selecting a extent larger than your contour area. That's why
Sir,
you are facing difficulty.
so how should I proceed, sir? I am unable to understand here.
Okay. Let's start from the remove first all the layers.
Okay, sir. Okay. Okay, sir.
Okay. Now check if there is any bounding box in map window.
Yes, sir.
Remove this also.
Sir, this is the this. If I close this map set, it will go, sir. That is the map set that grass tool has.
Okay. Now add your contour data.
Okay. And
Okay. Now what was the steps after this?
sir, here we have to go to plugin, grass, new map set.
Yeah.
Then this is the directory I am using where my contour data is stored.
Okay.
Then
Next.
next,
Hmm.
here select
Create a new location.
create new location. Let's take test. Then next,
Okay.
here I choose WGS 84
No,
EPH.
you have to select WGS UTM 42N because you are
42, sir.
WGS 84 and it's covering an entire world. See, yes. In the map below, you can check how much area is selected. When you're selecting WGS 84 only, it will cover entire area. So the boundary will be larger than your contour map.
So
That
here I have to
always
select 43N, sir.
yes.
Then click next.
Not 42N, I think.
42N. Okay. 42. 42N. Okay, sir. 42N.
42N. So it's covering an area of Udaipur region of which you are using contour data.
Okay, sir.
Now
Then
click on
next.
next.
Here,
Here you have to set current QGIS extent. Click on current QGIS extent.
yes, sir. I click. Oh, I should. I mean, in the PDF, they said click India like that. In the PDF, they said that. So, so I click that way. Then here,
Okay, you will also find some error because your entire extent on the left and right side there is blank area, so it might show an error.
so I have to zoom, sir.
Yes, zoom in and cover the entire screen.
Sir, wait a second. Where is zoom button here? Is it zoom? No. Okay, this is zoom.
You can zoom using scroll button.
Okay, sir.
Yes, now it's covering your entire screen. So
Okay.
yeah, now bounding box will be smaller than your contour area.
Okay, sir. So next test new map set. Okay, next open map set. Finish.
Yes.
New map set created. Okay. So
Now go to
okay,
mode.
sir. Now I got this.
Now your bounding box is smaller than your all contour area.
Yes.
So you will not face any difficulty or error in performing the final output.
Okay, sir.
Now
So,
run.
should I continue or you will
Yes, you
take
can
over?
continue. It will take only not more than 5 minutes.
Because I don't remember the next steps. That's why.
Okay. Write command for importing p.in
Dot sir,
OGR
is this
import loaded vector. First command.
sir this sir?
Import loaded vector. Yes.
Okay. For name
Assign,
for output.
assign the name as output file vector map. You can write contour or Udaipur contour.
Contour. Important. Yeah.
Click on view output.
Okay, something is.
Again, go to module. Your contour important is added in
Sir, contour is
background.
added, but nothing is coming, sir. This is the error I was having. I did a view output. Nothing is coming here. Is there anything I have to do here in advanced, sir?
No. Have you changed anything in your contour details? Okay. Show me the details or attribute table of your contour data.
Or maybe there is projection issues.
Which projection you are using of contour data?
Wait a second, sir. I think I was using 43 north or something. What is this? Wait a
No,
second.
if the contour projection for both the layer is different, then go to the properties of contour 100 meter.
Properties. Adding
Source.
information, na, sir? 43 north. So this is. So I will change the projection and redo it.
Okay, try to first close this QGIS and try again.
Discard.
It might show sometimes errors while opening.
Then no, I think the problem is with layer, open layer, add layer. Sorry, vector. Then go to contour shape. Open it. So should I try first reprojecting this to 43 and 42 north?
It's already in 42, 43 north now.
Yes, sir.
Check again.
This is in 43, sir. Because last time. This is in 43 north.
Okay, that's why it's an error. You have to reproject it.
Reproject.
From the DAM data, you did an error. So you have to again reproject your original DAM data into 42N, and then you have to extract contours, and then you can try to reverse the process from contour to generating DAM data.
Okay, sir. Okay. So should I do it now or now or?
You can try in between if you
Okay,
get
sir.
the time.
Sure,
And
sir.
if you face any difficulty, then you can ask me.
Sure, sir. I'll stop sharing now.
So, anyone else is facing any difficulty in from yesterday's session? I hope all of you have tried exercise which I taught you in yesterday's class related to Saga as well as grass. If you have any doubt, you can ask. Otherwise, we will start our today's session. So, in today's session, we will be covering exercises related to classification. In the first session, we will be covering unsupervised classification in both Saga as well as Grass GIS, and we will try to generate training sets for the supervised classification in both software Saga and Grass. And in the afternoon session, we will use that training sets for the classification and apply some filter on the output. So first we will start with Saga. In the Saga, you have to use a subset which you created in yesterday's session for this classification. So now I'm adding the satellite data. Okay. After creating color composite, so to classify the satellite data using unsupervised techniques, you can use ISO data method or k-mean clustering. So as per your lab manual, ISO data clustering method is given. You can check both the methods. So to perform this, you have to go to geoprocessing tool, then imagery, then classification, then unsupervised, and in the unsupervised, you have to select a method. So first go to geoprocessing, then go to imagery, then classification, then unsupervised. There are two different methods for unsupervised classification: ISO data clustering as well as k-mean clustering. So we will try to perform both the methods. First, I will start with ISO data clustering. So when you click on ISO data clustering, it will open a new dialog box where you have to select the grid system and your bands which you want to import for the classification. So I'm importing grid system. Then in the bands, I'm selecting all the four bands, which is blue, green, red, and NIR band. So in the cluster, you have to select create so that it will create a new layer with the classification. And if you want to normalize, you can check this box. And here you have to write some numbers for the maximum number of iteration and initial number of clusters and maximum number of cluster. So your output will be between 5 to 16 clusters. And if you want to color of the features as per your satellite data, you want that, then you can select this, otherwise it's fine. And in the start position, you can select random, periodical, or keep value. So I'm selecting as random. So after selecting all the values, you have to click on OK. I'm changing maximum iteration to 50 and initial number of clusters to 10 and maximum number to 20. Minimum number of sample will be 5. After filling all the values, you have to click on OK. So it will take some time. Once your process is completed, it will be added in your data manager. Now the process is completed. Let me change the color of output file. So most of the feature is visible. and choosing random color for identified classes. Then based on identified classes, we will change the color. So now almost all the classes have different color. You can select this synchronize map accent and go to any classes and identify the features. Now you can see this is water body and it is in brown color. So you can change the color from the table. So go to table by clicking on this object properties window, and in the color, when you click on this, it will open a new table where you have to select the cluster. You can write the name of cluster. So writing name as water body and changing its color to blue, and another one to any other color. So in the similar way, you can change the color of other classes which you have identified.
But here it seems that it is misclassifying. We know that there are like vegetation, but still it is showing blue color. So how can we trust this output? Because everything is blue here, and we know that water is not everywhere,
Uh,
especially in Udaipur.
okay, actually, because when you zoom into this portion, so some area which is showing shadow region, that was misclassified as water body. So you can change the number of cluster. Either you can reduce or increase so that the misclassification will be reduced.
And can we use association, like what we studied in the first semester? Um, for example, if there are hilly areas or vegetation, then it's not shadow, it's not water body, but shadow. So, can we use these kind of inputs in our classification?
Yes, yeah. When you are rectifying your output classification, at that time you have to identify different features and check if you're that where you are getting a misclassification or error. So you have to identify that pixel and then you can remove that error. So as in this class or in this file you have used that association technique and you find that okay, this is not a water body because this is a shadow area and it will be you're classified in forest area or vegetation class. So in the
I can
similar
also
way,
add here.
yes.
Here, see, in your course MGY 005, you have been introduced to several kinds of classifications. So, in it is supervised, unsupervised, object-based, then various soft classifiers and other hard classifiers. Okay, so when you generally the approach for classification, it is generally pixel based, and it means that it mainly the pixel values are or the DN values are used for uh, identifying various different features and classification. But the spectral signature alone may not be sufficient, as you see in this case, for correctly classifying all the classes. In that case, you can add some contextual information, you can add some ancillary information, maybe as another layer to the spectral bands. Okay, and that can be added, and then that could be used for reducing the classification errors. That way, that is one possibility. Another is that you can have some texture computation texture calculated and added that into classification process. So that could minimize your classification errors. There are different ways to improve the classification, but since you are starting just with the process of classification, this is trying to explain you what is the general procedure. But whenever you take a spectral signature, the important thing is also mentioned in your course self-learning material, that you need to evaluate the signature. You see whether it is misclassifying or it is mixing with any other class. In that case, you need to redo the sampling. I mean, the spectral signature collection, okay, and for classification, that needs to be properly done. So your classification output is as good as your the signature that you take. So if it is not good, the output is not going to be correct. If it is good, it is going to be good. Otherwise, so you have to be very careful about this. Okay, so we would appreciate if you can further read the detailed procedure for various classification, various types of classification, and what is the basic difference between them. Once you understand that, then you would be in a position to probably identify what kind of input, extra input that needs to be added in a specific way. And see, terrain to terrain and the area to area, those information may vary, because every image, depending upon various factors, for different features, there may be some misclassification. Okay, so that is why. Like for one example, I can take is suppose landform you are mapping. So for landform, particularly in the case of dunar landforms, so the for dunar landforms, it is all the same material. It is sand, and the compositionally it is going to be same. So if we are using just the spectral signature for classification of the different kinds of dunar landforms, it's not going to be correct. So in that case, you can add some other measures like textures or anything else for improving your classification. This is just one example. There could be different ways for different kinds of features and different kinds of terrains. I hope it helps you. Thank you.
Thank you, sir.
Thank you very much.
Please tell your friends, it is just only about 25 people attending the session. You tell your friends in the group to attend the sessions, because this is, once it is over, then there will not be an opportunity to attend the sessions. So those of you whose study center has some issue in conducting the council session, they should attend this council session, which is done scheduled by the Delhi Study Center with permission of their concerned regional center.
Okay. Now we will try to identify other classes, and then we will see how much error it's showing. So now let's zoom into this portion. Okay, as you find, this black pixel are showing vegetation classes. So I am assigning the black pixel as green color. Okay, now if you check your settlement areas in this cyan color, okay, I'm changing its color to red. This orange type pixel is also settlement. So I'm assigning it as red color. This yellow color is also showing some parts of settlement. So I'm assigning same color. So now if you check here, most of the image have vegetation and settlement and water body classes, but very few pixels of three more clusters. And now if you compare both the images, you can see your water body pixels are mostly misclassified, as well as your open land or agriculture area is not classified correctly, and vegetation also showing error. So now you can see in the master image, if you check, you can identify uh, water body, vegetation, agricultural areas, and settlement, open land. So we will try to reduce the number of clusters. So and check if it able to classify more correctly or not. So now I'm repeating the same process and try to reduce the number of clusters. Both initial number of clusters I'm selecting as 5 and maximum number to 10. I'm, I'm applying the cluster on the same output file. I'm not creating a new output file. So now you can see your forest is classified better than the earlier one. Now let me assign the color. White color pixel is settlement. You are getting one more black color pixels pictures. So if you check, this is also your vegetation class. Now, if you compare it with the earlier classified output, so your water body pixels are misclassification is reduced, and classification of accuracy of vegetation class is slightly increased, but uh, your accuracy of settlement areas decreased. So in the similar way, you can uh, trial and check with classification is showing error, and based on the output, you can reduce or increase the classes, and or you can also try different methods. So
Sir,
yes,
is there any impact of iteration, number of iterations, or number of bands we use for classification?
yes, it will affect the output. Definitely, you can also reduce the number of iteration or increase the number of iteration, so that if you're getting the less error, so it will be better. So I hope you
Okay.
understand the process, how you can check the accuracy, or how you can assign the different colors and check the outputs. I
Okay, sir.
hope process is clear.
Yes, sir.
Okay. So now we are moving to the next method. So we will apply k-mean clustering and then check among the ISO data and k-mean clustering which method is performing better. So for the process, go to geoprocessing, imagery, then classification, unsupervised. This time you have to select k-mean clustering. Now you can select grid system. In this, I am selecting all the four bands: blue, green, red, and NIR. And in the method, I am selecting uh, you can select minimum distance method or hill climbing method. So I'm selecting both the methods and maximum cluster as 10 and maximum iteration to 20, and I will keep the start partition as random, which is by default. After selecting all the values, click on OK. Now process is completed. I will add this to map. Now I will check by changing the color of output.
Hello.
Yes, please.
Yeah. We couldn't hear you actually, sir, when you were.
Actually, I'm repeating the same process. That's why I muted myself. So I'm just changing the color of output file so that I can identify both the different features in the classified image, and then I can compare how much error is getting I'm getting in output file.
Sir, when we did this classification, ISO classification, I am unable to see this table here. What in that they're doing color corrections now. I am
Yes,
unable to
you have to click on this. Then only you will see this icon.
click
Yeah.
on the interaction button, sir.
In at the table, you will see this table column 5 row 7 something, or you have to when you click on this, it will this icon, three dot icon will automatically appear.
Sir, I am not getting that, sir. Can I share my screen once if you can see it?
No, yes, please.
Yes, sir. Give me a second. Sir, I have selected this in the maps and I have used graduated colors to give it colors. Hope my screen is visible, sir.
Yes,
So I did ISO classification with default values, as you mentioned. Here,
change the type,
lookup table, sir.
discrete color.
Discrete colors. Then I generally use this rainbow. Okay.
Generally, by default, it will shown in a table format. And check in attribute.
Attribute. So where do I get?
In the object properties window, we are seeing that attribute.
Okay. Like this it is. Cluster.
It's showing error because you have changed the color type to discrete or something.
No, sir. First it was in grayscale. I just changed it to discrete, like how you showed it yesterday. It was. Actually, I did this way, sir. Grid imagery, classification, unsupervised. This is how I did. This is my.
Okay, perform it again. One more time.
Okay, sir. Give me a second. I'll just close this. Or
It's fine. You can run on the same.
no, it will take a lot of time, sir. No, it takes a lot of time. Give me a second, sir. I'll just close this fellow. I'll just remove this. Close. Yes. Okay. Sir, how do I remove this, sir?
Click on OK.
Okay. Then, sorry. Then how do I do? Okay, geoprocessing, grid, no, imagery,
Imagery.
unsupervised, ISO clustering. So here I choose that grid. Then here I have to choose all these bands or only.
No, only visible and near infrared. Your band one will not be used for this classification process.
Okay, 7. Only these
And
4.
yes, you can use this for. And
Then
sometimes you also use band, SWIR band for the classification process.
okay. So the settings are correct on them, sir.
Yes.
Okay. So I think it will take a lot of time. I think it will take a lot of time, sir. You can continue with your class. Once I finish, then I will let you know.
Okay, you can share, continue sharing your screen. So, uh, rest of you can try to
Okay.
change the color, and or if you are getting more error, you can try to resolve it. And if you face any difficulty in changing the color or classifying process, then you can ask. I think your system is hanged.
No, sir. It is slow only.
Oh,
It is going slow.
no problem. Okay. Now I'm sharing my screen.
Yes, sir. Yes, sir. Yes, I'll stop sharing.
Okay. I have changed the color uh, and the classified uh, output in which I am using K-means algorithm. So the first one, which is on the left side, is K-means cluster output of K-means clustering algorithm. In the middle one, my first color composite image, and on the right side, this is image which was classified using ISO data algorithm. So now if you compare both the output classified image, so you can see uh, the k-means clustering is bit more accurate than the ISO data clustering. So you can also increase or decrease the number of classes and check how much your data is accurate. So if you see your red classes is showing this settlement, and blue is water body, and the green color is showing the vegetation or the forest classes. These are the forest classes, but some error is there, but the error is reduced to much extent from the earlier classified image. And in the yellow color, you can see the agricultural areas. It's either shown or fallow area. So I have assigned both the classes as yellow color.
So the right one is k-means and the left one is isolated. So,
Yes.
and what are the parameters you used, in the drop down in the dialog
I'm
box for?
saying uh, in this I have used cluster. In the method I have combined both the methods, minimum distance and hill climbing method. And in the number of clusters I have selected 10 number of clusters and maximum iteration to 20. The rest all I keep as by default starting partition as random. I have selected the same number of cluster in both ISO data as well as k-means clustering. But here I have used both minimum distance as well as maximum likelihood or the L-clipping method as an algorithm in k-means clustering. In the similar way, you can try different algorithm as well as different number of iteration or methods for unsupervised classification. Or you can also try to reclassify using assigning a different uh, number of classes and check uh, whether your output is accurate or not. So I hope it's clear to all of you how you can uh, perform unsupervised classification using Saga. Is it clear to all of you, or do you have any doubt?
We will try, sir, once.
Okay.
Only we will.
Okay, should I give you 10 to 15 minutes for performing this exercise? Or do you want more time? I think 10 to 15 minutes will be enough. You can check. Even if you get low accuracy, if you understand the process, then it's fine. You can try later after this class.
Okay, sir.
Main purpose is to understand the process so that you can perform it. If you have any difficulty in any step, then you can ask. So I'm giving you 15 minutes uh, to perform unsupervised classification, in which you can try different methods or different algorithms. Also, once you finish with this, let me know so that we can move to perform the same exercise in Saga GIS. Sorry, Grass GIS.
Sir, can we get the material link from where we can see these steps?
Uh, Material link is shared to everyone in your mail. You can check.
Sir, I'm not receiving any mail from IGNOU.
Check. Have you checked your spam folder?
Yes, sir. Till now, I have not received any mail except the admissions, that your admission has been
Oh,
successfully done. Yes, sir.
I think mail is sent to all of you.
Sir, I'm
If
not.
you are write the correct email ID,
Yes, sir. I'm writing that in my chat box. If possible, please.
I'm sending the link of study material in the chat box.
Sure,
You can request for access.
sure, sir.
While requesting for access, you have to assign or write your details
Sure,
as your name, enrollment number, study center, your course, and your batch
sure.
in which you have taken admission.
Sir, now my classification is completed. Can you please see my screen? Hello, sir.
Give me a minute. First, I will share the link, then I will check. You can start sharing your screen.
Okay.
Just give me a minute. I have shared the drive link of MGYL008 folder in the chat box. You can request for access. Yes, please.
Sir, this is the classified result on the right.
Now, your table is visible. You can click on the table.
This one, sir?
Yes.
Oh,
From
okay.
here, you can change the color and assign different colors to the different your vegetation
This is
classes,
what happened.
everyone.
Okay, sir. Okay.
First, assign different colors to the different classes so that it will be easy for you to identify.
Okay.
Because
Okay.
here,
Yes, I
same
will do
color is
that.
assigned to different clusters.
No, sir. Thank you.
Well, is there anyone who is facing difficulty in performing unsupervised classification? अगर किसी को भी स्टेप में प्रॉब्लम आ रहा है या कुछ डाउट है तो पूछ सकता है.
So after we create the classified layer, and then we go to the table and change the colors as per our convenience, right? As per the correct one, what we think is the correct pixel and the convenience of so that it is easy to discriminate. Is that what is required?
Yes, you have to assign different colors to the different features. For example, if you are seeing the settlement, so as per the NRSC classification LUSC, so there are certain color code. So you can check that color code. For example, your settlement is uh, sign with the red color. Forest area is with the green color, dark green, and agriculture with the yellow color. In the same way, you can check the color code, and if you are not aware of this color code, but for this practical class, you can assign any color so that it will be easy for you to identify or differentiate between two different features, so that you can compare and check if your classified result is correct or not. So we are assigning just color for now, but in the upcoming exercise, you will try to learn how you can perform accuracy assessment on the classified image, either on the unsupervised classified image or classified supervised classified image. So your accuracy assessment exercise will be covered in upcoming session. Before that, it's advised to perform the classified, so your most of the area is accurately classified.
So the more bands that we incorporate, the better it will be for the classifier, right?
Uh, in some cases, when you are using SWIR band, basically your water feature is more clearly delineated in SWIR band, and your vegetation classes is uh, uh, showing higher reflectance in NIR band. So in the similar way, if you are using visible and near infrared, generally visible and near infrared bands are used for classified image. But if you are getting uh, or if your classes are more showing reflectance or in the spectral signature are much more clear in the SWR band, then you can also add SWR band while classifying the image. So you can check if your output is more accurate when you performing with visible and near infrared band only, or when you are performing with visible, near infrared and SWR band. So in different areas, the result may vary. In the landscape, there are more band also, such as panchromatic band, coastal aerosol band, and the thermal band. So when you are classifying these areas or different LULC classification, so those bands are not used. So you can use visible, near infrared, and SWR band for classification purpose. For the classification of rocks or identification of different rocks or uh, thermal variation in an area, at that time you can use thermal band.
Because I thought a settlement would be easier if we have other bands, because settlement and Sandy, for example, might give the same in
Yes, it will
visible.
show the same spectral signature. So first try to classify the image, and even if you get the same error, so you can perform NDBI, which is normalized difference built up index, and then you can merge that NDBI data into your classified image, so uh, that your built up area is more accurately classified. So you can also use NDVI or different indices in which your misclassified image is correctly classified, and then you can merge both the data for higher accuracy.
Thank you.
Yeah. I hope all of you have done unsurprised classification.
Sir, could you please provide the access for the Google Drive link? I'm not able to log in.
Actually, I do not have access. So Desmukh sir will give you the access, so you can contact him.
Okay, okay. Thank you.
And the sessions are recorded by study center, so you can contact Merit Study
Okay,
Center for the recorded session.
okay. Thank you.
Sir, I want to just confirm I have received the link for the Google Drive.
Okay,
I just want to confirm, is the file same? I just want to confirm, just a minute.
which file? You
Like the
get the link
folder
of
which I have received,
MGY08 now?
folder name is MGYL008 PDF,
Yes, all
and
the session.
data for exercise 1819 R programming, air
It's the same
pollution.csv.
folder. You
Is
have
it correct,
you
sir?
can download all the files. Yes, it's correct.
Okay. Can I share my screen once? I will confirm once. Because the files were last modified in 2024.
Yes, it was modified in 2024 and some files were added, but all the practical files are same. Even if there is any change in lab manual or any step is different, so the academic counselor will tell you the newest step.
Okay, is this the file, sir?
Yeah, it's correct.
Okay, okay,
Exercise
sir.
file.
Okay, okay, sir. Thank you.
Yeah. Any other doubt related to enterprise classification saga? So if you do not have any doubt, shall we proceed with the unsupervised classification in GraphJS?
Sir, I have a terminology related question. What exactly is the
Yes.
meaning of a map set? When we say map set, what does it mean?
Map set in Saga. Huh?
Yeah, in grass or maybe in any in general, is there a definition for a map set? Because I have seen it a few times here.
Uh, if you see in the Saga, in the map set, it will open your image or the satellite data which you are seeing in the map window. So now we are moving to the unsupervised classification part in GraphJS. So for this, you have to open the related satellite data and create a color composite. Then we will perform unsupervised classification. So once you open your grass, you have to add the file. Similar way you have done in yesterday's session. I hope all of you have finished till this step, created color composite. Once you created color composite, you have to create a map set and name it as unsupervised classification. Have you created RGB composite?
No, sir, we are having difficulties even in that somehow.
What difficulty you are facing?
So it says uh, projection error. Coordinate reference system of the data set does not appear to match with the current project. While the current project was what we created yesterday only.
Okay. Uh, Try to create a new map set, a new project location, and then first assign a georeferenced file from the same band, subset images, and then try to import all the bands.
Okay, sir. So- Okay, sir.
So
Will
can
do.
you please repeat the steps from the starting?
To importing the bands or
No, matlab, map set creation, all that. Because I think there is some confusion.
Yes, even importing the bands also there seems to be an issue in my view.
Oh, oh, run.
how many of you are facing difficulty in importing bands? First, we will solve the problem of importing satellite data. Then we will move to the next part, which is creating map set. So, how many of you are facing problem in importing satellite data in GraphGIS? No one is facing any difficulty. Someone told that he is facing difficulty in importing satellite data in GraphGIS.
Yes, sir. Sorry, sir. I had some big fault. I'm just sharing my screen, sir. Give me a second.
Yes, please. Okay, you have created database. Now create location.
Sir, this was like last time what we did, but I'm just trying here going to no, file
Now,
import
before
raster.
going to importing satellite data, you have to first create a location, project location.
So this is the location, sir.
Now, this is the database. Create new project location. Is this icon. Now assign any name. No need to change. You can keep it in by default folder. Click on next.
This is secondary. Okay.
Read CRS from your reference file. Now assign a file. We are working on a subset map, so it will be better if you assign a subset images georeferenced file.
Yes, sir.
Now click on next, finish. Yes. Okay. Now try to import satellite data.
The common transfer.
Browse.
Acha, we have to look, open one by one. Na?
Yes.
Okay.
No need to close this window. You can go to the required and
Oh,
open the same.
so here again I have to browse. Name the raster file. 3. There is no way where we can import all bands together.
No, in GraphJS you have to import one by one. Now when go to the required section. Now here you can change the band.
Yeah, okay, sir. Now,
Now create a color composite.
uh, so how do we do that? So, yeah.
Go to raster. Manage colors. Second option. Create RGB. Second last. Assign the name of output file. Either FCC. Okay, your first color composite is created.
Yes.
Anyone else is facing problem in any of the steps till now? Or all of you have created RGB composite? I hope all of you have created RGB composite. Okay. So now I'm moving to the next part, which is now you have to create a new map set and name it as unsupervised classification. So go to your this data tab, and here you will find a create a new map set in current project. So you have to click on this icon. When you click on this icon, it will ask for the name which you have to assign. So in this, write unsupervised classification and click on OK. When you click on OK, it will be added in the same map location. or project location as a new map set. So in this map set, your satellite data or the unsupervised classification data will be added. While in your permanent, your uh, all the bands and first color composite is available in your permanent map set. I am repeating the steps. After creating color composite, you have to go to this data section, and here you have to select this new map set in current project. So when you click on this, you have to assign a name as per given in your lab manual. You have to assign it as name as unsupervised classification and then click on OK. So when you click on OK, your unsupervised classification map set is added in the exercise 5 or other map location which you have created. So after this step, you have to go to the layers, then click on setting and grass working environment and map set access, and check if your map set is checked or not.
Sir,
Yes, please.
sir, before creating a new map set, we have to select the permanent database, or it will automatically create under that, sir.
So have you imported your satellite data?
No, sir. Actually, presently I'm in unfavorable situation, sir. I cannot do. I am just
No.
viewing this, and later I will try, sir.
Okay. So if you're creating a new project location, so that time you have to select a base map. And if you are creating a new map set in your project location, then you don't have to assign every time a new georeferenced file. So your georeference file will be for your map project. Every time you have created a new project location, that time you have to assign a georeferenced file.
Okay, sir.
So for example, in exercise 5, I have assigned already this band 2 as my georeference file. So if I creating any number of new map set, so I don't have to assign every time a georeference file. So if I'm working on this TMP project, which is a new map set, new project location. So this time, if I'm adding anything in this project location, so this time I have to assign a new georeferenced file, but not in the case of if you are creating a new map set in your project location. I hope it's clear.
Sir, compared to Saga GIS,
Yes, sir.
this software is very cumbersome. It's very
Yes,
difficult to remember the steps.
yes, it will be difficult when you are performing for the first time, but if you start continue working on this, then you will find it easier once you remember all the steps.
Okay.
So the next step is go to layer and click on setting. So in the layer, So in this layer, when you perform classification, output will be automatically guided here. So till now we have not created, we just assigned a map set as unsupervised classification. So when we perform unsupervised classification, so this will be added here. So the next step is you have to create an imagery group. For this, you have to go to imagery, then develop images and groups. So go to imagery, develop images and group. Then you have to click on create or edit groups. It will open this dialog box. So next you have to click on create or edit group. It will open dialog box, and this time you have to assign the name of the group as land set, and then you have to click on add button. So I'm assigning the name as land set, as we are working on land set imageries. Now click on add button. So the next step is in the add selected layers into group and change the map set to permanent, and you have to select all the 3 or 4 bands which you have imported. Here you have to select permanent, and now you have to select all the 3 or 4 bands which you imported. In my case, I have imported 4 bands, so I'm selecting all the 4 bands. After selecting the 4 bands, next step is to click on OK.
Sir, instead of 4 bands, should one not select FCC?
No, we have created FCC for visualization purpose. But when we are trying to perform the classification technique, I am using all the 4 bands: near infrared, band 4, 3, and 2, blue, green, and red. So
Okay, sir.
we are selecting these bands for unsupervised classification purpose. So all the 4 bands should be added. Now click on OK. And after this, your next step is to in the main menu, you have to click on apply. It will create a new group, and then you have to create a subgroup. So first click on apply.
Sir, here I am getting the order of the bands not correct. Blue, green, NIR, and red. How do we change the order?
You can drag one above the another.
Oh.
Okay. So we have created group. Now we have to create a subgroup. For the subgroup, you have to click on edit or create subgroup icon, and then you have to assign the name as all bands, and again check all, select all bands, and then you have to click on apply and OK. So to create subgroup, you have to click on this icon, which is edit or create subgroup. Now you have to select all. So we have selected all. Now click on apply. So we have to assign the name of subgroup also. And as per mentioned, you can assign the name as all underscore bands. You can assign any other name. Now your group and subgroup is created. Now click on OK. I am repeating the steps. Once you created your new map set, unsurprised classification, after that you have to create group and subgroup. For that you have to go to imagery, then go to develop images and group. Then you have to click on create or edit groups. So here you have to assign the name. So you can assign name as Landsat, and then you have to click on add button, and then you have to select in the drop down menu. You have to select permanent and select all the four bands: blue, green, red, and NIR band. Then you have to click on OK, and after clicking OK you have to click on apply. So your subgroup, your group will be created, and the next step is to create a subgroup. So for that you have to click on this icon, editor, create subgroup, and once you click on this, you have to assign a name to subgroup, and after that you have to click on select all the bands. So in your subgroup, all the four bands will be added, and then you have to click on apply and then OK. I hope all of you are following till this step. Are you performing with parallel, or you are writing down all the steps? Should I wait here for you to finish till this step, or should I proceed to the next step?
Sir, creating that subgroups, I mean, why are we doing this?
In your group, sometimes you might have selected more bands which you required for the group, but in that group, if you are working for different purposes and you are creating more than one or two subgroups, so in that subgroup you can select a different number of bands. For example, for a one subset, one subgroup you are selecting true color composite bands, and for the another one you are selecting astroglare band also, so that you don't have to create a group again and again. So in the same group you can select all the bands, and then you can create a subgroup for performing different actions.
Okay, but we are not seeing any bands under unsupervised classification. So will that
Uh,
affect?
we have just created group and subgroup in the permanent map set. So
Okay.
from the permanent map set, we will be using all the four bands and spectral signature of all these four bands, and then we will try to classify the image, which will be added in your unsupervised classification.
Okay, sir.
Shall I move to the next step, or should I have to wait for 1 or 2 minutes? All of you have created group and subgroup. If you will not respond, I will assume that you have created group and subgroup.
Sir, we have created, sir.
Okay. So now we are moving to the next step, which is to classify the image. For the classification process, you have to go to imagery, then click on classify image, and here you have to select cluster input for unsupervised classification, which will open a new dialog box. So go to imagery, then go to classify image, then select clustering input for unsupervised classified. It opened a new dialog box. Here you have to select input imagery group, which you just created, group as well as subgroup. So in the group, I have to select land set as we created or assigned group name as land set, and in the subgroup we have created all band subgroup. So now you have to assign the name of output file, which file will contain the spectral signatures of all the 4 bands. So in the output file, you can assign name as signature underscore 10 classes or more than 10 classes. If you want to assign or creating more classes, you can assign name accordingly. So now I'm assigning name as signature underscore 10 classes. Once you fill all the detail, next you have to go to this optional tab, and in the setting tab you have to select the initial number of classes as 10 and cluster separation as 1, and rest you have to keep the same. So in the same, before closing, you have to go to the settings section. Here you have to assign the initial number of classes. So in our case, we are selecting 10 number of initial classes. So I'm assigning 10, and in the maximum number of iteration, you can select any number. So as per the lab manual, I am selecting 30, which is by default. And in the percentage convergence, you can select any range between 0 to 100. I'm keeping it as by default. After filling all the values in setting tab, now go to the optional tab and name the output signature file and save the output folder, then click on run. So I am assigning the name as signature underscore 10, and you have to select the folder where you want to keep the output file. I have assigned the name to output file containing initial signature as well as the output file, and assign the folder. After selecting all this, click on run. uh, we have to open one more dialog box, that is I cluster, which is already open, and I maximum likelihood. You can also search for I dot mix likelihood. So in this dialog box, you have to select input in imagery group, which is your land set, and output as all bands, and input file. Now signature is created. Now I have to select estimate, land set, all band, and in the signature you have to assign the signature 10 classes, and in the output file I am selecting output file name as maximum likelihood classification. And the unsupervised. After selecting all the values, click on run. Now your output maximum likelihood classification file is added in your layer window. You can uncheck and see your output. I hope all of you have followed till this step.
No, sir. I did not understand.
Okay, should I repeat the steps?
Yes, sir. That I cluster and I in max.
Okay. So first you have to go to the imagery, then classify image, then you have to open this clustering input for unsupervised classification. In this dialog box, you have to select input imagery group which you created.
Okay.
In the sub group, you have to select the subgroup which you created. and you have to assign the name of output file which contain your respective signature from all the bands which you have selected.
Sir, when did we create signatures, sir?
We are importing all the bands now. So we are just assigning the name of output file. It will contain the signature from all these satellite data,
Oh,
the bands.
so we just give a random name.
Yes. Once you assign name, go to the setting tab.
Okay.
Here you have to select the number of classes. You can select 10, 15 or 20. As many number of classes you want.
Okay, sir. So should I enter 10 here? As you
Yes,
said.
you can write 10.
Then number of rows and columns over which same pixel is taken. That you don't have to fill. Na?
No,
Cluster separation 1 and then
rest keep the all values as by default.
okay.
Now run.
Run.
Yes.
Uh, okay. So I just give me a second, sir. Error option report file exists to overwrite use override flag.
I think you have assigned the name which is already present. So you
Sir,
can change the name.
where should I assign in the required thing?
Can you please share your screen?
Okay, sir. Window. Sir,
Okay. In the maximum I dot cluster, you have assigned all the values. Now click on run of the I cluster.
sir, I have given this as you said.
Remove all the names. So once your signature file will be created, then only you can write.
Sir, this is the required file.
Okay. Now click on run. Okay. Your respective signature is created.
Okay.
Now go to the I maximum likelihood dialog box.
Okay, sir. So here I have to give.
Select your imagery group and subgroup.
Why is it not working? False.
Right.
Give me a second.
Oh.
Okay, so I just don't do anything here. I just do this thing. Input file signature, I have to
Close this dialog box once and try to open it again. Close. Okay. Now open it again. Either you can write the command or you can go to the imagery and
okay, so but
if you are writing command, you have to go to the tools section in the console window. Now you can write.
wait a second. This is the one, na?
Yes, MLC. Now select your group and subgroup.
Here I have to write something. Okay.
Yes, respective signature which you just created. And now you have to assign a name to output file.
So this is what? Maximum likelihood.
Yes, you can write maximum likelihood or unsurprised result, anything.
Run, sir?
Yes. So your unsupervised classification pilots added, and you can see it in your map window.
Okay. Okay, sir. Thank you.
Yeah. Anyone else is facing any difficulty in performing unsupervised classification? Try to perform the same classification and by increasing the number of clusters, either 15 or 20, and let me know if you face the difficulty, uh, which output is showing the more accurate result in the grass GIS. You have 10 minutes. You can perform the same exercise again, but this time you have to increase the number of cluster to either 15 or 20.
Sir, in this grass, how do we change the color code?
Okay, first try to complete this, then I will show how you can change the color.
Sir, I did actually.
Okay,
Wait a second. This is I did with 20. This is with 20,
okay.
and then this is with 10. So there is no difference. I mean, there is difference, but I just wanted to, if you can see here, especially in this area.
Okay. So now if you want to change the color, right click on any layer,
Sir,
uh, set color table interactively,
wait.
just above the histogram.
Okay. I clicked, nothing happened. Okay.
Your color table is
No, my system is slow. So
okay, no problem.
stuck.
You can wait. It will be open in a new window. So you can check if the new window is open.
Okay, it opened. Yes.
So here you can change the color or assign different colors to different classes.
Oh. Okay, this is load color table. Can't understand. Set. Mhm. Sir, how do I increase this?
To increase this, there is an option for add below clear all. Just you can see add. You can write and assign the different colors.
Acha,
Hmm.
we have to write the value also.
Yeah.
So if I want 7 colors, say suppose, clear all, then add. Oh, I get 7 values. Oh, So how do we, so till 2, it is red. Okay. 4, yellow. Then 6, orange. Yellow. Then 8. 8 is the light blue. Then dark blue. Dark green. Okay. Upper. Okay. Something is missing here. White.
So you have created 10 clusters, but you are assigning name for only few classes, color for only few classes.
Okay. So how do
That's
I
what
add more here instead of removing this?
you can just click on add button after selecting the classes, number of classes which you want more, either 3, 4 or 1, and click on add. Your classes is added. Now you can assign the value and color code.
Okay. Probably I'll do something like green. Okay. How do I know which class is this?
Sorry.
Water bodies are still white. So how do I know? I have added like how 10 classes. How do I get the?
Okay, you are classifying or assigning value to the class that unsupervised result in which you
So
have classified
I did
10.
this values manually.
In the in your case, you have 17 different classes, not the 10. You
7.
can check. You can enter your raster value range between 1 to 17.
Okay. So that.
So you have 17 different types of cluster.
Okay. So no, the values went till 100. Okay. Sir.
If you assign the different values, then the color will not be added in your output file.
Now it is correct. Yes, my values ranged from 1 to 17. So there are 17 classes.
Yes,
What is this value? Is it class? Because how can it be 15.4?
because it's between the 15 and 14. So it's assigned now different sets of color, the different classes. So if
Okay.
you want, you can remove these classes and keep the remaining classes as
No,
9, 10.
no. The question is how how can the see you are giving class names class 1, class 2, class 3, class 4. How can
Hmm.
this be class 10.6?
Depending on the probability with
Oh, okay, sir.
between those two different classes.
Okay, sir. Okay.
But here I have one question. In Tarun, can you open that dialog box again, what you just closed?
Yeah.
Yeah, that window. Yeah, so if you see here, for water body, the value is 1. If you scroll up, just in this color legend, yeah.
Yes, yes.
So, but when you uh, assign the new
Yeah, I
color
gave
code,
two.
there we did not assign 1, so maybe that is that the reason why the the water body was white.
Yes. So I think that is the reason.
If you do not assign color to any cluster, then it will show the white color. And even if you assign the value higher than your cluster value, then that color will not be visualized. You cannot see the color in your output file. So you have to assign the range as well as color in between the ranges of your clusters.
Okay, sir.
So these values 1, 2.8, 4.2, what are these? What is the significance of this number?
Actually, these are showing different number of clusters between 1 to 17.
Hmm.
It's not the DN value, right? In
No,
the
no, it's not the
classified
DN
number.
value, it's the number of classes cluster in unsupervised classification.
Number of clusters means because here 2.8, 4.2, 4. What does 4.2 mean for the third color?
So you have selected between 10 to 20 different clusters. So your value with number 1 is one cluster, 2.6 is second cluster, 4.2 is third cluster.
Okay, sir.
You can change the value and assign the different colors to all the clusters. But it must be ranges between, for example, in this case, the number of clusters ranges between 1 to 17. So it must be between 1 to 17 only.
Okay.
So basically, this number doesn't mean anything. It can be XYZ. It's just the color that matters or the category, right?
Yes, the number is showing the clusters. So if you assign the number more than 17, suppose it's 18 or 20, so that color will not be shown in your output window. So, because you have only 17 cluster, and if you assign number more than 17, so it will not show the colors because you do not have 20, the cluster with the name 20.
I think it would have been easier if the clusters were just named or numbered 1 to 17 integers rather than 2.6, 4.2. If they were just named like, 1, 2, 3, 4, that would
Yes,
have
you
been
can
easy.
reassign the number if you want to,
Yeah.
from 1 to 17. You can change the number, but it must be between the total number of clusters.
Okay,
You
sir.
can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 till 17.
3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I have to add more. I have to add how many? Oh, sorry. Add.
I think beyond 12, everything will be in one particular
Hmm.
category.
15, 15, 15, 16, 17. There are two more. Here, can we assign these things randomly, sir?
Randomly means number between 1 to 17. Or
Not like that, sir. Coloring.
yes, you can assign a random color, and after identifying different classes, you can change the color also.
Oh, okay. Okay, sir.
So in this case, uh, your pink color is something else, green color is something else. So after assigning different colors to different classes, you can assign the exact color for your output file. For example, if in this case, water body is shown in blue color. So suppose it's not in a blue color, a red color, and you identified that your water body is showing in a red color. So you can assign the red color, sorry, change the red color to blue color. So after identifying different classes, you can assign same color to different clusters also. If your different cluster is showing the same feature, for example, if your agriculture was shown by two or three different clusters, so you can assign same color to all the clusters which is showing your agriculture classes.
Okay,
So
sir.
here it is only a coincidence that the blue is for water here. Otherwise, it can classify anything as that particular. Any color can come instead of.
Yes, you can change the color, and if it's by default, it's blue, then you don't need to change. And
Yeah,
if it's not by default blue, then you have to change the color to blue.
yeah, yeah.
Thank you, sir.
Welcome. Any other doubt related to unsupervised classification? Once your unsupervised classification is completed, you can export the result layer and save it in your system. And if you want to add different map elements such as north arrow, scale, or legend, etc., so if you can do that also. And after assigning all the map elements, you can export it as the JPG image or PNG format, etc. I hope it's clear to all of you how you can classify unsupervised classification in GraphGIS. If you have any doubt, then you can ask. Otherwise, we will move to the next experiment, which is creating training sets for the supervised classification. So I hope all of you know the difference between supervised and unsupervised classification. Do you know the difference between unsupervised and supervised classification or not?
So supervised is where we give the training set.
Okay.
Unsupervised is what it does right now. I mean, what we learned right now.
Yeah. In the unsupervised classification, we just assign number of clusters or number of classes which you want. For example, 10, 20, 15, 12 or something. Based on the different number of classes we identify in the satellite data, and uh, based on the assigned number of clusters, the system will assign automatically the different clusters. While in the supervised classification, first you have to give the training signatures or the training spectral signature of different clusters or different classes of LULC or any other classification. For example, if you are having different number of classes such as vegetation, agricultural land, water body, road network, built up area, mining area, or mm, tidal floods, etc. So you can assign different spectral signature, give a small portion as a sample sized pixel. It must be more than 2 to 3 pixels minimum. So based on that spectral signature, the system will assign the uh, clusters based on that signature which you gave them as a training sample. So if you give the minimum, suppose you have assigned 5 number of training samples. So based on all your images, the output will be uh, give you 5 number of classes. If you assign more number of clusters, so or more number of training sample, so it will assign the more number of classified or different features. Generally, we use unsupervised classification when we don't know about the area, or for example, if you are new to any area. So in this case, you are not familiar with the Udaipur area. Most of you are. So we are assigning unsupervised classification. So after the classification, when you compare both the images and you found that your result is mostly accurate, and you have assigned required number of clusters and identify all the different features which might be present in your real world, and after that you save the output file and then go to fieldwork for the accuracy purpose and check the map whether your map is classified your classified map is accurate or not. For example, if you're in your map some area is showing vegetation uh, or forest area, so you have to check in the field that uh, at that location if it's forest area or any other classes is there. So based on your field data and the data which you have collected in the field, you have to reclassify the images. And once you are familiar with your study area or the area on which you are working, you can reclassify the output. This time you can assign the different number of cluster and training samples as you are now familiar with your study area. So you know that at this location your vegetation, water body, or any other LUSC classes were there. So based on that knowledge, you assign different training sets, and then you uh, again classify the output and again check for the accuracy assessment until and unless you get the most accurate classified image. So when you check the accuracy assessment, in most of the terrestrial area, your accuracy must be more than 80%. So if your accuracy is less than 80%, it will be not used for uh, any purpose, or it is not uh, defined as a trusted output map. But in the case of coastal areas, due to the heterogeneity, the classification output might be or accuracy might be slightly less than the terrestrial part. So generally in the coastal areas accuracy must be bit more than 70%, while in the terrestrial area your accuracy must be more than 80 or 90%. I hope it's clear now.
So I have a question, sir.
Yes, please.
When we say that we need to assess the accuracy based on uh, the classification results, so is it through ground field work or is it by taking another set of correctly identified that we are sure that these are pixels that are correctly classified, and then we use it to assess accuracy, or we go to the field?
So it will be better if you go to the field and then check the accuracy. But in some cases, for example, in mountainous region or in the coastal region, it might be muddy or marshy areas, which is not possible to go in that area. So in that cases, you can select or perform less field work, and or you can use higher resolution satellite data. For example, if you have classified different number of cluster and generated unsupervised or supervised classified map, then you can cross check it with high resolution data, which might be your Sentinel or List for data or Google Earth satellite data. As Google Earth satellite data have higher resolution, so you have to rely on that high resolution data. You cannot compare with the same resolution satellite data. I hope I clear your doubt.
Thank you very much.
Any other doubt related to this exercise till now? Okay, if you do not have any doubt, we will move to the next exercise, which is to creating training samples for supervised image classification in both Saga as well as in GraphGIS. So there is one link given in your exercise 6. In this, your different number of classes is given as per the NRSC or ISRO. So you can choose any one level 1, 2 or 3 for the classification purpose based on your requirement. So we will perform supervised classification on the same satellite image or same subset which we created in yesterday's session. So first import your satellite data subset image in Saga. So once you import your satellite data, then you have to create a shape file for your training samples. So for that you have to go to the geoprocessing tool, then go to the shapes, then click on construction, and then you have to click on create new shape layer. Go to geoprocessing, then shapes, then construction, and then go to create new shape layer. When you click on that, it will open a dialog box where you have to assign the name of shapefile and number of attributes. So, and you can also select the shape type, either point, line, or polygon. So as per mentioned in your lab manual, you can write the name as signature and assign the shape type as polygon, and rest keep the value as by default. So I'm assigning the name as signature and shape type as polygon, and rest keeping all the values same. Then click on OK. So once you click on OK, your new shapefile layer will be added in your manager window. You can see this layer is added. So if you open the attribute of this layer, as we do not have selected any polygon or created any polygon, so it's showing blank. So now what we will do, we will try to create some samples for training purpose using this first color composite. You can also use true color composite for creating spectral signature or training samples. So to create this training samples, first you have to open your spectral signature and add to the same map which you have opened. So right click on this layer, click on add to map, then click on the layer first color composite map section, then click on OK. So now your this shape layer is added on this map layer. So when you create any polygon, so the lat long value or coordinate will be read from this map layer. So now go to any uh, classes, water body, forest, open area, agriculture land, or settlement, and zoom into particular part and see where you get the pure pixel. For example, all these pixels are of uh, water body. So if you select or create a polygon and it containing any other, for example, if in this case you are seeing different pixels which is not of water body. So if you create a polygon and in this polygon all these pixels are added, so it will result into error when you create a final output file. So to create a polygon, you have to click on the signature layer. Then you have to click on edit and click on add shape. And then you have to click on action button, which is arrow. And then you can create a polygon. Now right click on signature layer. Then click on edit. Click on add shape. Now go to action button and mark a polygon. So when you are finished with creating a polygon, you have to click right button, so your polygon will be added. In the similar way, you can right click and click on add part and go to other area where your water bodies are present.
So basically, we are populating the signature polygon layer with by creating polygons in that layer, right?
Yes. Your spectral signature will be read from this training samples only for the water body. So it will be better if you select all the different spectral signatures of water bodies. You can select as many number of training sample in a single classes. For example, I have selected only one polygon in water body. Now I am adding one more polygon for the water body. So I have created two polygon for water body. Now I am moving to this water body, which is having slightly different spectral signature than the earlier one. Earlier, both the water bodies were black in color. Now this is showing some sort of blue color. So again, you have to click on add part, then create a polygon. In the similar way, you can create 5 or 10 polygon, or if you want more, you can create more. So based on your number of classes, or uh, based on your preference of the classes, you can select different number of spectral signature in a particular class.
Sir, can you please show me how to create this polygon and then create the shapes?
Okay, have you created shape file?
Yes, sir, I did.
Have you added it on your map window?
Map window. Add to map, sir.
Add to map, and then select this layer which is open.
Oh, okay. I added. Then I went to add shape. Then I selected the uh,
Action button.
section button, and then trying to clicking. It is only clicking a triangle, sir.
Okay, can you share your screen?
Yes, sir. So this is a previous classification. So here I added this to the map, and then I click here, go to edit, add shape. Like that, it is happening. Am I doing something wrong?
Are you clicking or just dragging your mouse?
Sir, I'm clicking, sir. First, I will stop all of this. Maybe I'll recreate all of this.
No, no need to recreate. You can uh, first close this FCC composite. This is opened.
Now I have to open
Now
it.
open a new false color composite in a new map window.
Okay. Then
Now add your signature file to this new map.
okay.
Now try to add polygon feature. First add this signature layer to this map. Have you added or no?
Yes, sir. I added.
Okay. Okay.
I'll
Now
just
try to create polygon.
zoom. First, I'll do the zoom so that fraction. See, or else maybe add to map. Okay.
Okay. Can you use your mouse?
Yes, sir. I am using mouse only, sir.
The external mouse or the laptop mouse?
No, sir. Normal mouse only, sir. I'll close this thing again.
Okay. Sometimes might show error due to this laptop mouse, because sometimes it shows as
New Okay, in this thing, I have to add a map. Go to this, click OK. Then I select the action button. Then I just click here. Nothing is coming, sir. Acha, I didn't take it. Huh? Okay, add shape.
Okay, do one thing. Create one more shape file.
Yes. Okay. So let's zoom this. Okay, and then geoprocessing, shapes, construct. Click on create a new shape layer. Signatures. Is this fine, sir? This default.
Yes, it's fine.
Okay.
Click on OK.
Then right click, add to map. Press one. Okay. Then go to edit, add shape, select action button. So nothing is coming, sir. You want me to close this software and open it again?
Yes, you can try it once. Anyone else is facing the same issue or? Click on OK.
Okay. Saga. Open.
Have you chosen polygon as the shape type?
Yes. Okay, it's loading. Then I do this add to map. Then go to this RGB composite, then select 3 and then 2. Apply. Okay, then I do that. Then I geoprocess, shapes, construct, create new shape layer. Okay.
No, not OK. You have selected point layer this time.
Point, yes, yes.
By default, it's point layer. You have to change.
Yes, yes. I will change that. Shapes of construct. Basic polygon. Okay, now I'll change this to signature. Okay. Then okay. Then I add this layer to okay. Then I go to edit, add shape. Then I click action button. से नहीं हो रहा ना सर?
तो
आ गया. Nothing is going. No.
do one thing.
Sir.
Create a polygon and save it as a feature. Let me check if your polygon is creating or not.
So how do I save as feature?
No, first go to edit.
Okay.
Add shape.
Sir.
create a polygon.
Shit. ये ऑटोमेटिक उधर क्यों जा रहा है? ऑटोमेटिकली सेलेक्टिंग. Maybe something is wrong. Mouse. Okay.
When you are completing a polygon, you have to right click.
No, sir. Here
Hmm.
I'm clicking. Automatically, it is selecting 2 points.
Okay, now do one thing. Click on edit selection. Yes. Okay, your polygon is creating, but your cursor is not clearly showing all the pixels. So you can remove this attribute and then try to just select 4 points. Then you can add a shape.
Sir, how do I delete this, sir?
Go to the attribute of this signature file. Attributes.
This is the attribute. This is the attribute. Maybe.
So click on show. Okay. Now delete this one. Now close this table.
Still it is there. It left. Okay. Then I will select again.
Now again you can try to create polygon. Your cursor will not show a polygon, so you have to save that. Just right click and try to right click on the map, add part. Okay. Now go to the other water body and try to create a new polygon.
Sir, I'll create here one.
Signature.
Sir, I clicked 4 points. Then I right clicked. Nothing is coming.
Don't worry, your cursor is not showing any polygon, but when you save it, your polygon will be created.
Sir, how do I save it, sir? Again?
No need to save every time.
Okay, okay.
There is something, some issue with your system only.
Okay, sir. Maybe the software has some issue as of now. In my system, I am also not getting the crosshairs symbols are here.
Crosshair symbol will be activated when you open two different map side by side. To compare both the images, then it will appear.
Okay. Okay, sir. Thank you. I'll stop sharing.
Okay. So I was demonstrating how you can add shape. So I was creating polygon for water body signatures. Now click on add part. So I have selected 4 different polygons showing different spectral signature in the water body. So to save this in a one single class, go to this signature, or you can right click on the map and then click on edit selection. So it will ask for apply changes. When you click on yes, so all the 4 polygons which you created just will be added in a single class. So if you open your attribute table of the shape, you will see a single polygon. You can write the name as water body. And close this. Now you have to select different spectral signature from other class. So this time I am selecting spectral signature of vegetation or the forest area. So even in the forest area, you have to select the correct pixels. So in some of your pixels, which is showing a same spectral signature with agriculture areas, so it will be better if you select the more pixels which is showing different classes than the agriculture, different spectral signature than the uh, agriculture classes.
Sir, I did not understand your point. Why do we choose different? Suppose we want to classify agriculture and vegetation, we use different spectral signatures.
Just for the surprise classification, if you can see, your agriculture area is showing pink color. Okay, and in your forest areas where vegetation density is lesser, it is also showing the pink color, but different shades. So if you select spectral signature in the vegetation class which is showing the same spectral signature of your vegetation class, so it will affect your output result. So either your vegetation classes will be identified as agriculture classes, or your agriculture features will be identified as vegetation or forest class. So to remove that error, we will try to uh, give the spectral signature of the forest classes with the higher density. So there will be less chances of misclassification or error.
But since the pink color near the forest will be same as the pink color of agricultural land, still it will classify as the agricultural land, right? If we create a category for agricultural land with pink color, it will classify the pixels near the forest, which are supposed to be forest, it will classify as agricultural land, irrespective of whether we choose the pixels differently. So I understand what you mean, that we choose different forest and agriculture. We are careful in selecting the appropriate pixels, but the light pink near the forest, which is supposed to be forest, will be classified as agriculture in any case.
Yes, there will be misclassification. That's why it will be better if you select the separate spectral signature for both the classes. And if in the final output you are getting some pixels which will be classified as a different classes, then you can either manually remove it or apply different filters which we will learn in the next session, for the minority filter or majority filter, or then you can check your accuracy assessment. So now I am adding spectral signature for forest or vegetation class. So to add this, click on add shape and create a polygon. If you see, even in your forest areas, some shadow areas showing black spectral signature. So this spectral signature or this pixel will be misclassified as your water body. There are mostly chances of misclassification. So when you apply different filters, for example, if your few pixel are in this area is classified as water body, and remaining all the areas nearby are classified as forest area. So when we apply the majority filter, so based on the majority classes nearby, so it will automatically change the spectral signature or the final output to forest class. you can select different features. Either, for example, if I'm getting uh, there is river body which will be uh, showing the same spectral signature as water body, but near the river you might get sand. So you have to select a different spectral signature for that class, and you can choose open area or scrubland, forest area, agriculture land. If you want to keep sown and fallow land as a different classes, then you can, otherwise you can merge both the classes as in agriculture land. I am selecting only 3 or 4 polygon for each different classes. You, if you want, you can select more than that. For the demonstration purpose, I am just using less number of polygons. I have selected the spectral signature of water body and the vegetation class. So if you go to attribute table of your shapefile, it will show 2 different classes. So I am assigning different ID and different name. So this is my vegetation class. So I have assigned different ID and different name to both the classes. In the similar way, I will create training or spectral signature for remaining classes. This is the mining area. If you want to keep it in your built up class, then you can. If you want to classify it as a separate class, it's up to you. Then you will get familiar with the steps in Saga GIS. You have already learned how you can perform surprise classification in QGIS. So process is similar, but your steps will be slightly different in different softwares.
Sir, if I created polygons for particular categories, say suppose vegetation or agriculture, then I created another shape for built up. Okay, Now imagine I want to add some part into the vegetation part. How do I go back and add to or delete wrong image?
So to delete that, go to your attribute table, select any one class, and then there is option for delete selection. And if you
Uh,
want to delete all the classes, then you can click on this delete all record.
no, sir. Say suppose you added water body na, earlier. Now you say suppose you find some other water body with different reflection. So you want to add that part here. So how do you add?
So to add that part, you can assign the same ID and same name.
Hmm, okay.
Hello.
Yes, please.
Sir, are we taking a break right now?
Okay, I am waiting for others to create a spectral signature if they
Okay.
find any difficulty in performing this.
Okay.
After 10 to 15 minutes, we will take a break of 20 minutes. I think that will be sufficient.
Hello, sir. Hello, sir.
Yes,
Sir, I have created the classes. I'll just show you.
yes, please.
Sir, can you see?
Yes, it's visible now.
Sir, I have water, vegetation, agriculture, sand built up. Then again, I created sand and built up with the same
Okay.
ID and name. So that is what I did now. So I'll show you. But everything is in one color only. Is it not supposed to come in different colors, the polygons?
No, that's fine if you assign different ID and different name.
Okay.
So what about others? All of you have created spectral signatures, or you want more time?
Sir, can you please? Your voice was breaking. Look.
Okay, I was asking about others if they have created spectral signatures or if they want more time. Okay, I will wait for 2 to 3 more minutes. Then I will show you how you can, using this spectral signature, you can create surprise classification file. Then we will take a break, and after the interval or break, we will proceed with the next part. I hope all of you have created spectral signature. So now we will be performing surprise classification based on the spectral signature which you just created. So your result might be vary from person to person depending on the training samples which you selected. So to perform surprise classification, first you have to go to the geoprocessing, then go to imagery, then go to classification and select the supervised classification of grades. In this you have to select first grade system, then you can select number of bands which you want to use for classification purpose. So after selecting band, click on OK. In the classification you have to click on create. In the training areas, now you have to select the spectral signature which you just created. If you give your name as a signature, then you can select that. And if you have selected other name, then select accordingly. And in the class identifier, you have to assign either ID or name. So if you have same ID but different name, then you can select different name. And if you have selected different IDs for all the classes, so you can select ID also. So all the IDs with the same number will be classified as a single class in the final output. Or if you have different names and the same ID, so in that case you have to select name so that all the classes with the same name will be classified as a single class. So I am selecting name as class identifier, and in the methods you can select any one of these method. You can select minimum distance or malware distance, maximum likelihood, or anything. So I'm selecting minimum distance. You can also perform with other algorithm also to compare the output of different algorithms. So I have selected minimum distance. So if you want to keep the threshold value, so your classes will be classified accordingly. So you can, otherwise you can select as 0. So after selecting all the values, you can click on OK. It will take some time and your surprise classification will be added in data manager window. So now I'm adding it in a new map. You can see this. I'm opening both the files side by side. So when you open two different window, at that time you will see this map synchronize icon and crosshair icon. So now you can compare the output in both the classes, and if you want to change the color, you can change by going into this object properties window, go to table and change the color. I have selected less colors just for the demonstration purpose. If you want more classes, you can select accordingly.
Maybe for barren land, maybe white will be better or something like that. Great. Because right now it's very difficult to distinguish.
Because in the spectral signature there are some error, so final output is saying much error. So you can either change the algorithm, or if other algorithm is working fine, then you can select it, or if you want to change your spectral signature, then you can change. In my
Changing
case,
spectral signature means, sir?
you can create a new polygon layer with a spectral signature, and in that you can see which classes, or you can also modify this spectral signature file. So suppose in my case, the vegetation classes and the built-up area is misclassified. So I can delete that misclassified spectral signature, and then again add new polygon for that class. You can go to attribute, you can show, and then you can delete the classes which is showing higher uh, error, and you can add more classes in the spectral signature and then reclassify your data. I hope you understand the process how you can classify. So it will be better if you add more than uh, 10 or 5 spectral signature in each classes, so that your output will be better. If you select less spectral signature, it will show more error. Because for the demonstration purpose, I have selected only 2 or 3 classes in each classes. That's why it's showing a more error. But in your case, you will see the less error if you have selected more number of classes in the spectral signature, more polygons. I hope it's clear how you can perform surprise classification. Now we will take a break, and after break, uh, we will be performing continuous same exercises. Those who have find or getting more error, you can modify your spectral signature and then reclassify, or you can also change the algorithm and try again. So once your output will be uh, accurate, or most likely to be accurate, then we will proceed with the next part.
Okay, sir.
I think 20 minutes will be enough, or you want half hour break?
Sir, half an hour would be great.
Okay. So
But sir, before we leave, just look at my result.
yes, please.
Unfortunately, also I am unable to get this crosshair. So this is my result.
Okay.
From distance. So here I do not have the crosshair. Only thing is I can link the zoom, link the views, but no zoom, no crosshair. Do you know where can I get that option?
Which version you are using?
So the latest one I downloaded, yesterday.
Okay. It might they might have changed some options. So what is in the link view? Can you check
Yes, sir.
in the link view?
Link view. Synchronizing map extents.
Yes, it's synchronized. You can click on this.
Ah, that one only, sir. These two are synced.
Okay, now you can see.
No, sir, I did not get.
Okay, no.
ठीक है, sir. This is still how. So
Okay, I have to check once again in the newer version.
okay, sir. Okay, sir.
Actually, I am working on the earlier version, older version. So I will check and then tell you if it's
Okay.
there or
Thank you,
we
sir.
have to do something for that crosshair.
Okay, sir.
So now it's 2 o'clock. We will be meet again at 2:30 p.m. You have break for 30 minutes.